Chapter 3, Part 1. When Humanity Looks at Black Holes with Ambition. After 2 chapters full of philosophy, theory, and scientific drama, let's get a bit more practical. What could black holes actually do for humanity's future? Sounds insane, right? For centuries, we've seen black holes as cosmic monsters, things that do nothing but swallow unlucky objects drifting by. But as the old saying goes, know your enemy, and you'll win every battle. So if we truly understand black holes, could we flip the script and turn them from enemies into allies? First up, black hole energy, which honestly sounds like something out of a Marvel comic, but it's rooted in real science. Around black holes, especially in the accretion disk, that swirling maelstrom of matter falling in at nearly the speed of light, enormous amounts of energy are released. Theoretical physicists, including Roger Penrose, once proposed that we could harvest energy from this process. In fact, the Penrose process suggests that if you toss an object into the spinning region of a black hole in just the right way, you could extract energy, basically hacking the universe's wireless charger. Another angle is harnessing Hawking radiation. Yep, the very thing that once made physicists want to flip tables. In theory, if we could create or find tiny black holes, the radiation they emit as they evaporate could be tapped as an energy source far more powerful than any nuclear reactor. Sounds epic, but here's the catch. Making a mini black hole is still pure lab daydream, since our current technology isn't even close. In other words, this path is about as feasible right now as cooking rice with laser eyes. Cool idea, no application yet. Beyond energy, black holes fuel our dreams of space travel. Wormholes, the cosmic tunnels we mentioned back in Chapter 1, could, in theory, allow humans to hop from one planet to another faster than pulling up directions on Google Maps. If one day we prove wormholes can exist and remain stable, black holes might become the greatest teleportation gateways in human history. Of course, at the moment, the odds of passing through a wormhole safely are about the same as jumping into a volcano and hoping not to get burned. But hey, dreams are dreams. The truth is, whether it's black hole energy or wormholes, these ideas remain on paper. Yet the research itself has already given us plenty. Ultra-sensitive telescopes, insanely powerful physics simulations, even AI algorithms that reconstructed the first ever black hole image. The M87 Cosmic Donut. All of these are direct byproducts of humanity's dangerous game with black holes. In the next part, we'll dive deeper into the story of black hole energy. Could it become the limitless power source that saves humanity, or will it stay as nothing more than a beautifully crazy dream? Chapter 3, Part 2, Energy from the Darkness. When people hear the phrase black hole energy, they often laugh. Wait, how could you harvest energy from something that even light can't escape? But the truth is, black holes are actually colossal cosmic power plants, where physics plays out at such extreme levels, it's almost impossible for us to imagine. Let's start with the accretion disk, that blazing whirlpool of matter swirling around a black hole. As gas and cosmic dust spiral inward at nearly the speed of light, friction heats them up to millions of degrees Celsius. The result? They emit more energy than an entire galaxy's worth of stars combined. If humanity could somehow place a cosmic turbine there to catch it, solving the energy crisis would be as easy as flipping a switch. The only catch, to get that close without being shredded into space puree, we need technology way beyond anything we can dream of today. In other words, it's like wanting to install a windmill inside the eye of a Category 5 hurricane. Works fine on paper, but in reality, good luck. Roger Penrose took things further with his bold idea called the Penrose process. He imagined that if you dropped an object into the black hole's spinning region, the ergosphere, just right, the object could split its energy, one part swallowed by the black hole, the other flung back out with more energy than it had before. It's like tossing a brick in and getting the brick back, plus a free power bank. Sounds nuts, but mathematically, it checks out. Then there's Hawking radiation. As mentioned earlier, black holes aren't immortal, they slowly evaporate over billions of years by emitting quantum radiation. If we could create tiny artificial black holes, the radiation they pump out would equal billions of nuclear power plants. Just one sitting in your living room could run your AC 24/7 for millennia, no electric bill required. Of course, this scenario is still pure daydream science, since making mini black holes is about as feasible right now as turning instant noodles into Michelin-starred cuisine. The fun part is, even without actually tapping black hole energy, the research itself has inspired real breakthroughs. Here on Earth, like new ideas for nuclear fusion reactors, advances in supercomputer simulations, and even the AI algorithms that reconstructed the first ever black hole image, that famous M87 cosmic donut. By trying to decode how the universe works, we keep stumbling onto innovations that reshape daily life. But the big question lingers. Are black holes really an untapped energy goldmine waiting for us, or just a beautiful sci-fi dream we'll argue about for centuries? In the next part, we'll turn to humanity's second big ambition for black holes: space travel. Could they become gateways that carry us beyond the Milky Way? Chapter 3, Part 3, The Gateway Through the Cosmos. If harvesting energy from black holes sounded insane, the next idea is on a whole new level of beyond hope, using black holes as gateways through the universe. And the star of this story is the wormhole, the cosmic tunnel we first mentioned back in Chapter 1. Mathematically, wormholes pop up as special solutions in Einstein's equations. Picture the universe as a flat sheet of paper. If you draw 2 points, A and B, normally you'd have to travel the long path across the sheet to get from one to the other. But if you fold the paper so that A and B touch, then punch a hole through, you can jump across instantly. That's a wormhole, a shortcut through space-time. Sounds like cheating in a video game, but in fact, it's backed up by the math. So, what do wormholes have to do with black holes? Some scientists speculate that black holes could be one end of a wormhole, with the other end, well, nobody knows. It could be in some far corner of our own universe, or even more wildly, depending on your taste, in a parallel universe. If that's true, then black holes aren't just cosmic shredders, but also intergalactic teleportation gates, free shipping included. Too good to be true? Of course. Real life isn't interstellar. Wormholes, if they exist, are insanely unstable. Try flying through one, and you'll likely get spaghettified before you can snap a selfie. To survive the trip, you'd need a bizarre material called exotic matter, something that hasn't been observed yet, but theoretically could keep a wormhole open instead of collapsing like a garage door. The catch: exotic matter currently exists only in theory, right up there with your dream of buying a cheap flying car at the local market. Still, the dream of wormholes has irresistible allure. It doesn't just torment physicists, it fuels pop culture. From Star Trek to Interstellar, from Japanese anime to Marvel comics, wormholes are always the magic bridge connecting distant worlds. Even if we've never stepped through one, the idea itself pushes us to dream beyond our cramped little Milky Way cradle. So the big question: will future generations casually hop through wormholes like elevators to tour galaxies billions of light years away? Or will wormholes remain forever that unreachable rainbow on the horizon? In the next part, we'll dive deeper into the real impact of these ideas on humanity's future. Will black holes forever symbolize destruction, or will they become the driving force behind our greatest leaps in history? Chapter 3, Part 4, When Darkness Becomes a Driving Force. At this point, you might be wondering, okay, black holes sound both cool and terrifying, but what real impact could they have on humanity's future? The answer: more than you think. First, let's talk about mindset. Black holes are living proof of just how complex the universe really is. Every time science collides with black holes, we're forced to invent new ways of thinking. From developing X-ray telescopes, to supercomputers simulating space-time, to the AI algorithms that reconstructed the M87 black hole image in 2019. All of these were side products of trying to understand the abyss. In other words, black holes are like strict teachers, frustrating, demanding, but the kind that makes students smarter by piling on the hardest problems. Second, black holes fuel dreams. Think about it. Without the idea of wormholes, would humanity dare dream of one day leaving the Milky Way? Without the concept of black hole energy, would we have the audacity to attempt impossible projects like nuclear fusion reactors? Black holes are like a strange fire. You can't touch them, but just looking at them is enough to inspire us to reach further. And finally, black holes remind us of humility. The universe doesn't revolve around humanity. We're just tiny creatures trying to make sense of a vast cosmos, still hiding secrets that stump both Einstein and Hawking. The deeper we study black holes, the more we realize we're only standing at the doorway of knowledge. Instead of despair, that smallness fuels us. Knowing we're not enough makes us yearn to go further. So what might humanity's future look like with black holes? Maybe one day our descendants will harness black hole energy to power entire planets. Maybe they'll board starships that slip through wormholes unguided, tours of parallel universes. But even if those futures never happen, black holes will still have done something extraordinary. They've forced us to keep asking, to keep dreaming, and to keep moving forward. In the next part, the conclusion of Chapter 3, we'll wrap it all up. Why black holes, once dismissed as monsters of theory, have become one of the greatest driving forces for science and human civilization. Chapter 3, Part 5, From Monster to Motivation. At the beginning, black holes appeared as half-real, half-imaginary ideas hidden in the dusty equations of the 18th century. They were dismissed as mathematical monsters, things that existed only on paper, far from reality. But over time, from vague speculation to rigorous evidence, black holes have become one of the central characters of modern science. And in the conclusion of this chapter, we see clearly, their journey is not just about the cosmos, but also about humanity's ambition and imagination. Black holes once ignited fiery debates among scientists, from Einstein's skepticism to Hawking's defiance. They nearly broke theoretical physics with the information paradox, and they also fueled the public's imagination through films and novels. But in the end, black holes have become mirrors reflecting the power of human intellect, always questioning, always doubting, always pushing forward. As sources of energy, black holes inspire dreams of limitless power. Through wormholes, they open doors to horizons beyond the Milky Way. For science, they are the greatest natural laboratories, where the universe tests the limits of every theory. And for civilization, they have become symbols, darkness that is both terrifying and alluring, both devouring and enlightening. Perhaps in the future, we'll never truly tame black holes. But that doesn't matter. What matters is that their mere existence is enough to drag humanity out of complacency, forcing us to look up, to move forward, and to dare to dream beyond reality. Closing Chapter 3, we see a beautiful paradox. Black holes, symbols of destruction, have become some of the most powerful sources of inspiration for creativity and progress. And in Chapter 4, we'll turn to a new perspective, the philosophical, mythological, and cultural stories, how black holes stepped out of laboratories and into human imagination and consciousness.